Good day, folks. Welcome to my channel, Number Pen. So, today's video is a continuation of what we learned yesterday. Uh, just to recall, yesterday we looked at slope of the tangent to the curve, right? We did try and understand why the slope of the tangent to the curve is dy by dx. Now, we're also going to look at an extended topic to what we saw yesterday. And today is what is the slope of the normal to the tangent, right? And this, you will find this as a common question in most of the examinations. When we talk about equation of the tangent or the slope of the tangent, we also talk about slope of the normal to the tangent, right? So a normal is nothing but a straight line which is perpendicular to the tangent line, right? So you have the diagram on your screen where you are seeing a continuous function y is equal to f of x, and this line what I have marked here, passing through this point p, which I am highlighting right now, is the tangent, right? So this is the tangent. Let me probably call this line as pq. No, you already have a p, right? So let me call this as ab. So AB is the tangent, and the line perpendicular to this is called the normal to the tangent, right? So nothing but normal to the tangent is it forms an angle of 90 degrees with the tangential line, which is AB. So AB and CD are perpendicular to each other is what we mean here. So so the slope of the line, like what we saw earlier, is nothing but the angle that the tangent makes with the x-axis, right? So in this case, I've called this as alpha, which I'm circling out here for you people. And then the angle which the normal to the tangent makes is the angle beta. Now, what we are going to do is we're going to draw a relationship between the slope of these two lines, which will be very useful in the problems that follow us in the subsequent videos, right? You have this diagram here. So what I'm going to do is, I'm going to draw your attention to these three angles, alpha, theta, and beta. So tan alpha is, but let me use the symbol. I'm getting better at this. I know this. Now, tan alpha is, let's call this as, call this as m1, which is the slope of the tangential line. And tan beta is the slope of the line which is n2, right? Which is the slope of the normal line. I'm just taking you back to the diagram here. So tan alpha is the slope of AB, and tan beta is the slope of CD, which is normal to the tangent, right? Now, we know that the sum of angles in a triangle is 180 degrees, right? So we have another new angle called theta here, and we know that theta plus beta, you know, uh, phi is 180 degrees, right? So I'm going to write this again. Let me use theta plus theta is 180 degrees, which also means that beta is 180 degrees minus theta, right? So let me write that out for you. Right? And we also know that alpha plus theta plus this third angle, which is 90 degrees, is equal to 180 degrees, right? we know that, so we have alpha plus theta equals 90 degrees, right? So we have alpha plus theta equals 90 degrees. And why is that? Because the sum of angles in a triangle is 180 degrees. You already have 90 degrees. So the remaining two angles have to sum up to 90 degrees, right? Now we know that tan of 90 is infinite, right? And so what is tan alpha plus theta will be equals tan alpha plus tan theta whole divided by 1 minus tan of alpha tan of theta. So if tan 90 is going to be infinite, then the denominator of this particular equation has to be 0, right? So which means 1 minus tan alpha tan theta equals 0, which means tan alpha tan theta equals 1, right? Only then the denominator of this equation will become infinite because it is equal to tan of 90, right? Now we have tan alpha with us, which is m1, and we have tan theta, which is tan of 180 minus your beta, which is nothing but the slope of the normal, right? Now, what is tan of 180 minus beta? It is minus of tan beta, right? So I move the minus out. Tan of beta equals 1. And what is tan beta? I'm just drawing your attention to this line here. I'll just draw this for ease of understanding. So we bring this here again, which is m2 here, right? So what happens? Minus m1 into m2 equals 1, which means m1 into m2 equals minus 1. So the product of the slope of the tangent and the slope of the normal to the tangent is always minus 1, right? So that's what I wanted to understand. I wanted you all to understand as a part of this video. I hope you liked my video. That's all we have for today. Keep watching my channel. Do subscribe if you like my videos. I'm happy to take feedback from my new subscribers. Have a good day. Thank you.